Which is pretty easy. 10% of the country is left, right, and center. No, this is established.
I missed the call.
Already know.
Yeah, they're playing genocide.
The plan to save the world.
So how's everybody doing?
Wait a second.
Wait a second.
We're not running yet.
You're not running?
No.
Are these the extra Kevlar cameras that won't go blurry?
Oh, they'll go blurry, don't worry. You ready?
Yeah, I'm going.
All right.
All right, go ahead.
Go.
Oh, that's fuel. We gotta have fuel.
Can this be on camera?
No, don't worry. This is a Tea Party event. We have everything on camera. All right. So I know that it's been a while since we've had one of these events, and I appreciate that you may have forgotten the usual forms. But we do start, as always, if I can have you upstanding, as you are able, to recite a Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Well spent.
You know, it does my heart good to hear that. I'm a simple man with simple tastes. And I'm a very lucky man because I'm surrounded by some of the finest people in this world. One of these fine people is Mr. Christopher Mader, president and producer of the MMP radio program, and I'm proud to say, our Dean of Journalism.
So this has been an event coming over a couple of months. The idea came down through our good friend Hal Shurtleff. If any of you know him, he runs Camp Constitution. And of course, like any event that we run here at the Tea Party, all it takes is a germination. That's all it takes. And then of course, and then somebody gets hold of me on the phone, and then it just goes from there. So we've been pushing this out all over social media and getting people. I cannot believe this. This is so amazing. All the people who have come to be here tonight. So I've never met Lord Monckton. I've only known him from his videos, his dissertations on the IPCC, countering anthropogenic climate change. It wasn't until I went to pick him up tonight, or this afternoon, out in Pittsfield, Mass. If anybody's driven out to Pittsfield, Mass, you know it's a hell drive. It's just you're out there. You're literally going to New York. You're going out to New York, you can throw a rock and you're in New York. There was a hell drive out there. I pick up Lord Monckton. All I had to do was ask one question. And for the next 2 hours, that ride just disappeared. Next thing I know, I'm in Worcester. Folks, I'm telling you, I couldn't pay enough money for a college education for the education I got in that 2 hours. I got a complete dissertation on communism, progressivism, how it relates to climate change, how they're making this whole thing up, they're purposely doing it, they know what they're doing, and to a certain degree they don't know what they're doing. You'll hear it all tonight. These are the things that we do on the Meat and Potato Show. These are the things we do for the Worcester Tea Party. We find these people, we bring them here, and we present them to you. Ladies and gentlemen, it is my most humble honor, Lord Christopher Monckton.
My lords, that's me, ladies and gentlemen, at the legislative drafting unit of the Intergovernmental Panel on Climate Change, they do not call a spade a spade. Oh no, they don't do simple. They call it a one-person operated, manually controlled, foot-powered implement of simple and robust, yet adequately efficacious lignometallic composition, designated primarily by no means exclusively for utilization on the part of hourly paid operatives deployed in the agricultural, horticultural or constructional trades or industries, as the case may be, for purposes of carrying out such excavational tasks or duties as may from time to time be designated by supervisory grades as being necessary, desirable, expedient, apposite or germane with regard to the ongoing furtherance of the task or objective in hand, or on the other hand underfoot, Secretary General. Now, I'm going to speak to you in plain English tonight. And we're going to begin by recalling 2 letters of the NATO alphabet, the phonetic alphabet. Now, everybody knows what Bravo stands for, and everybody knows what Sierra stands for. But I'm going to prove to you tonight, somebody's got there already, well done, that global warming is Bravo Sierra. Now, I got into this global warming nonsense by accident. I was at home in the Scottish Highlands, looking out over Loch Rannoch with eagles and ospreys wheeling overhead, distant mountains fading away, and the phone rang, and it was the manager of a discreet hedge fund in London who said, "We have a problem." He said, "All my investors want to go into green investments because they're worried about global warming. Can you tell me whether global warming is a problem?" And I said, "Well, yes, all the scientists say it's a problem." And then I first looked at what they were saying when I worked for Margaret Thatcher at 10 Downing Street. And I told her they were saying it was a problem, but I said, let's wait a little and see whether it really is. And that has turned out to be rather good advice, because when I then carried out a 1-month-long investigation for this hedge fund, I discovered that global warming isn't a problem at all, but that there were so many people making so much money pretending that it was, that this was not going to go away in a hurry. And in that too, I proved to be prescient. Because sure enough, here we are. That was 2006, this is 2018, 12 years later, and I'm still, to my astonishment, on the subject of global warming. And frankly, I think it's time, don't you, to bring the global warming nonsense finally to an end. And so, working with a very talented team, including a professor of climatology, a professor of statistics, a professor of control theory, and I'll explain why that later, 2 more control theorists, an expert on the worldwide electricity industry, an environmental consultant, and an award-winning astrophysicist from the Harvard Smithsonian. That is the team of co-authors that has put together the short, devastating, crippling, learned paper, which is now out for review at one of the top learned journals of Marxist climatology. And we're going to try to persuade these wretches to publish our paper, because we have, in 6,000 crisp words, mostly equations, proven beyond all doubt that global warming has been vastly, and I mean vastly, exaggerated. There will be some, there has been some, but there won't be enough to worry about. And I thought I would begin rather challenging by trying to explain something of the mathematics behind the discovery we made. And putting it at its simplest, these climatologists must all have been Scotsmen, because they forgot in their calculations that the sun was shining. And in Scotland there's this, I come here and everywhere I look there's this large yellow thing in the sky. Now we don't have this in Scotland, so I'm really quite intrigued by it. But the climatologists forgot that it was shining, and they left it out of their calculation. And the reason why this mistake that they made has gone unnoticed for so long is that when they dropped it out of the equation that tells you how much global warming you're going to get per doubling of CO2 concentration, which is the standard yardstick that everybody uses, they used an equation which was still a correct equation, but it wasn't a useful equation. It couldn't tell them the answer they were looking for. Now, it is generally accepted among climatologists, and so we go along with everything we cannot prove to be wrong in what they say, that if you double the amount of carbon dioxide in the atmosphere, as we will do in about 150 years from now, compared with today, then what you will get is a warming directly caused by the fact that the CO2 is in the atmosphere and it wasn't there before, of approximately 1.04 Kelvin, which is about 2 Fahrenheit. It's not a lot. It's certainly not enough to worry about. But, as you will know, the figure that the Intergovernmental Panel on Climate Change publishes for the warming at doubling of CO2 is not 1.04 Kelvin, it's between 1.5 and 4.5 Kelvin with a central estimate of about 3. And the computer models are now saying 2.1 to 4.7 Kelvin with a central estimate of about 3.4, which is about 6 Fahrenheit. And that would be kind of almost a big deal if it were true. But as I shall hope to prove to your satisfaction this evening, and as we shall hope to prove even to the satisfaction of the Marxist journals of science, this is not true. And I will reveal to you gradually how little the global warming by doubling of CO2 will actually be. Now, why then do they say that it's going to be so much bigger than the amount of warming you get just from putting the CO2 in the air? The reason is that they say that things called temperature feedbacks, which are knock-on amplifications of the original warming, that happen just because the atmosphere is a bit warmer, it then gets warmer still. They say that those feedbacks account for between twice the direct warming from CO2 and 5 times the direct warming from CO2, and in the sillier papers 10 times the direct warming from CO2. Some papers are predicting as much as 10 Celsius of warming per doubling of CO2. And it is these feedbacks that are the main reason why they think there's going to be catastrophic global warming. Now, the mathematics of feedbacks comes from control theory or systems theory, which is a branch of physics. And our cameraman here is familiar with this branch of physics. And so he will tell you whether anything I say about this branch of physics is Bravo Sierra. And I assure you, sir, that it won't be. Because we have a professor of control theory and 2 control engineers on our team of co-authors of this paper. And they have put me straight on this mathematics to the point where even I, a mere ignorant layman, can understand it sufficiently well to explain the main points of it to you. Now, before I do that, I want to just take a vote. How many of you would like to endure the 5 minutes of mathematics that it will take me to explain completely the error that is going to happen? How many of you would like that? How many of you would not like that? You're fine. And how many of you couldn't care a damn either way? You're in the wrong place. So, in that case, I'm going to give you, if I may, just 5 minutes of control theory, a branch of physics. And we're going to use this handy prop here.
Leave it there.
That Christopher kindly got.
No.
It's going to collapse on me, so Somebody will come and hold it up, I expect. There we are.
Needs to come back though.
Very good. You do that. Okay. But it has to be propped against the wall or it falls over, I think. I brought it forward so they could see it. Anyway, there we are. They can see it. Okay. Now, this is what's called a feedback loop. And it's a really simple feedback loop. It's simpler than the feedback loop you'll find in most textbooks of control theory. And why is this? Because when the original textbook of control theory by Hendrik Wade Bode of Bell Labs, then in New York, was published in 1945, he imagined that you had to have an amplifier with a feedback circuit, but you don't. Any amplification of what is called the input signal to the circuit can simply be added to that input signal before it's fed into the circuit. And that allows you to replace the input and output nodes, which are junctions of the circuit, with a single node. This is known as a summative node because things are going to be added up in it. Now, I should explain that in a dynamical system, which is a system which changes its state over time and can be expressed mathematically, like an electronic circuit, or a control process in a factory, or climate. Feedback mathematics is exactly the same for all of them, which means you can build an electronic circuit to mimic how the climate will react with feedback. Am I right or am I right? Yes, I'm right. Good. Now, here then is a feedback circuit, and you can imagine, if you like, electronic circuit. It's sometimes easy to understand it that way. We have the input, I'm going to do this in temperature, the input temperature, which we call the reference temperature. So it's T with a little r underneath it for reference. Reference means before we have any feedback. Over here, we have the equilibrium temperature, T with a little q below it for equilibrium. So the equilibrium temperature is the temperature you get after feedback, after the output of the feedback loop has operated. And in the middle, and you don't need to have a great IQ to understand that, is the feedback loop itself, because it's shaped like a loop. See how easy this is? Now, what we need to know is what is the transfer function that converts the reference temperature before feedback to the equilibrium temperature after feedback, following the operation of the feedback loop. And that transfer function, also known as the feedback amplification factor or system gain factor, is a number which we will label A. Now the feedback factor, which is the fraction of the equilibrium temperature that is represented by the feedback response rather than the original input temperature, is called F. That's all you need to know, and it gets even simpler as we go along. Now the electronic circuit feeds in through the summative input node, so we've already got TR is in there. And then it comes out here, and it goes round the feedback loop, and every time it goes through a rectangular block, by convention, it is multiplied by whatever's in the block. So it's TR times F. And round it goes again, TR times F squared. Round again, TR times F cubed, and it goes on to infinity. So what we need to know then, to get the transfer function, is what is the sum of the convergent infinite series, f to the power 0 plus f to the power 1 plus f to the power 2, all the way up to f to the power of infinity. Now you may think, wow, that's going to be a really big sum. But the convergence condition to make it converge to a definite amount is that the absolute value of the feedback factor f has to be less than 1, as it is in the climate. And under that convergence condition, that apparently complicated infinite series of successive powers of f, and then f times f, and then f times f times f, all the way up to infinity, works out that simply it's 1 over 1 minus f. That's what it comes out. So we might write that on in blue here. We just put it equals 1 over 1 minus f. That's what that comes out. So then, if you want to know what TQ is, it's simply TR, the input signal there, the reference temperature, multiplied by 1 over 1 minus f, is equal to that. It's really simple. So your transfer function A is equal to 1 over 1 minus F, and your equilibrium temperature is the reference temperature times 1 over 1 minus F, or simply the reference temperature times A. See how simple this is. But now we have to introduce what the climatologists got wrong. They define feedback as responding not to the entire input signal, but only to some fraction of the input signal, which is delta TR. Delta simply means a change in that quantity rather than the whole quantity. And they say that therefore the output signal over here is delta TQ. Now that is still, believe it or not, a correct equation. But the problem is that the sunlight, which is the biggest part of the input signal in the climate, gets dropped out if you only take the changes in the sunlight temperature that are caused by the greenhouse gases. And leaving out the sunlight means you can't find an easy way to derive this vital quantity A here. If you know that you have to include the sunlight so that you can get that quantity, it all becomes easy. So how do we do that? And I told you this would only take 5 minutes, I've got 2 minutes left, so I'll explain. All you have to do is use a thing called the fundamental equation of radiative transfer. You've heard of that, sir? Yes, good. And we need to know that the amount of ice on the Earth would be rather more without any greenhouse gases than it is today, and that therefore the albedo or reflectance, the amount of light bounced harmlessly straight back out, would go up if you've got more ice around. So instead of being about 0.3 or 30% reflected straight back out harmlessly, it's going to be 42% reflected straight back harmlessly. The incoming solar radiation is 1,364.625, something like that. Watts per square meter. We divide that by 4 because the sun sees the Earth simply as a disk, but actually it's a sphere. And the ratio of the surface area of a disk to that of a sphere is 4. So we have to share it out. Sphere to disk is 4. So we share it out, and so we divide that by 4, and then we do a little manipulation with this special equation, and it tells you therefore the temperature, before you had any greenhouse gases, would be too high, except water vapor, which we count as a feedback, would be 243.3 Kelvin. We then add another 11.5 Kelvin for the presence of the pre-industrial greenhouse gases. So that in 1850, the reference temperature would have been the sum of those two, which is about 254.8 Kelvin. Now what then was the equilibrium temperature? Well, we don't have to work that out because we measured it, and it's 287.5 Kelvin. And so the ratio of the equilibrium temperature to the reference temperature is, of course, the transfer function. So we immediately know what that transfer function is because we've included the sunshine. It makes the whole calculation really, really easy. And the answer, of course, is 1.13, as you have already calculated. So, 1.13. But that was in 1850. Some of these feedbacks are what are called non-linear. They don't respond in exactly the same way. The more the temperature, the more they respond. So we have to allow for that. So then we go and do the same calculation for 2011. And that means we have to add, on the reference side, 0.7 Kelvin caused by the greenhouse gases we have added before taking account of feedback. And after taking account of feedback, we add 1 Kelvin this side. So that gives us about 288.5 over 255.5, which, as you have already worked out, is, as it was in 1850, 1.13. It doesn't change. Why doesn't it change? Because the 254.8 Kelvin that we started with in 1850 is so much larger than the 0.7 Kelvin that we've added to it with our activities. It's 375 times larger, that the tiny change that we have made since 1850 is so minuscule in relation to the hugeness of the temperature caused by the sun and by the pre-existing greenhouse gases that it just basically doesn't make any difference. Much as you would all have suspected anyway, the point of doing it this way is that that actually proves it. And that is the end of the proof. It is as simple as that. The transfer function is 1.13, and so if you have CO2 causing directly 1.04 Kelvin of warming, and that's a figure they would pretty much accept because it comes from one of their papers. 1.04 times 1.13 is 1.17 Kelvin. That is the bottom line. That is how much warming we can expect. 1.2 Kelvin, if you like, per doubling of CO2 concentration, and not the 3.4 that's their best estimate, not the 4.7 that's their top end estimate, and not the 10 Kelvin that some really silly papers are trying to suggest. 1.2 Kelvin per doubling of CO2, so the next question is how long does it take to double the CO2? And the answer, of course, is about 150 years. So in 150 years from now, we can expect the temperature to be roughly the equivalent of a doubling of CO2. We will see probably around 1.2 Kelvin. It's not a lot. It's not dangerous. It's not difficult. It's not to worry about.
Is that even a bad thing that it's limited?
It's actually a very good thing. There's a good question there. Is it a bad thing that it's warmer? No, it's a good thing that it's warmer, because then at the what will happen is you'll get huge areas of northern Canada and northern Russia, which suddenly at the moment they're on the permafrost, which is useful. Melt the permafrost and bingo, you've got millions and millions of acres of extra agricultural land. But do you lose agricultural land in the hot parts of the world? No, you don't, because there's going to be more water vapour in the atmosphere already. The Sahara by 1981, because of the global warming up until that date, had shrunk by 300,000 square kilometres as greenery began intruding in areas where greenery hadn't been seen in living memory. And that's gone on ever since. And the greening of the planet that's resulted from the extra CO2 in the atmosphere, because CO2 is plant food, is now somewhere between 15 and 30% increase in the total biomass of all trees and plants on Earth. This is known as the net primary productivity of the plant. They all have a pompous name for a simple concept in science, but that's what it is. The total volume of trees and plants on Earth has gone up between 15 and 30%. Now you've heard of deforestation and forest fires and this and that, it's all our fault and the plants are all being done. No. The satellites show quite clearly that the planet is rapidly getting greener, and the main reason why it's getting greener is the extra carbon dioxide in the atmosphere because it's plant food. In order to make photosynthesis work, you have to have sunlight, which of course the climatologists don't know is happening. You have to have chlorophyll in the leaves of the plant, and you have to have water, and you also have to have carbon dioxide. And all the carbon dioxide in all the trees and plants on Earth, does it come from the ground? Does it come from the soil? No. It all comes from the air. And the fact that we are putting more of that CO2 in the air means the plants can all breathe more easily. Now you may think I'm just making this stuff up, so let me tell you how we know that the plants can breathe more easily. The reason why we know is that the plants breathe through mouths or stomata on the underside of their leaves. If you look at it under a microscope, you see these little holes where the air can get in. Now, the number of these stomata that are on the leaves of the plants has been declining because the CO2 has been increasing, so there doesn't need to be so many of them, so they are adapting to the extra CO2. Now, why should they reduce the number of their stomata? Because they lose water through the stomata. And if they can reduce the number of stomata they need to breathe and live on, then they don't lose so much of the precious water on which they also need to survive. And so we can see from the decline in the average number of stomata on the leaves of the plants that they are enjoying the extra CO2 in the atmosphere. That is how they tell us. Thank you very much, good old man, you're doing the right thing. Give us more of this plant food. And isn't it a paradox that the people who call themselves Greens are advocating the one policy that the plants don't want? which is to reduce the amount of carbon dioxide in the atmosphere. Now, there are only two potential scientific excuses for not wanting more CO2 in the atmosphere. One of those is that there's going to be a dangerous lot of global warming. And we have now proven, and proven beyond all peradventure, it's very, very simple, that that's not going to happen. There's not going to be a lot of extra warming. There's going to be a little extra warming, but that's not going to be dangerous. It is going to be a good thing in that term. So you would agree that there's not going to get much global warming. That's a proof. There's nothing wrong with it. Absolutely right. He knows what he's talking about. He's a physicist. Now, the other supposed reason why you might not want CO2, anybody like to tell me what it's called? Ocean acidification. So let me give you a little bit of background on this. There were virtually no papers on ocean acidification in the journals at all until about 2004. Then suddenly they began to explode, and now there are huge numbers of papers on this every year. Now, does this mean they've suddenly discovered that if you add CO2 to the atmosphere, you change the relative partial pressures of CO2 in the air and in the ocean, and therefore there'll be a bit more CO2 in the ocean? Have they suddenly discovered this? No. What they've done is they've suddenly realised that this is true, and that they're going to need a fallback position. So they have begun calling ocean acidification the evil twin of global warming. And they're saying that, oh, all the corals are going to die, and they're already dying on the barrier reef, and I can't bear it. And you may think that in hamming it up like this, I'm parodying what they do, but barrier reef scientists, one or two, that have literally been blubbing on television because it's absolutely wonderful for getting grants. Now, my brother and his three strapping sons, all of whom have their licenses to do scuba diving, they're all as fit as fleas. They go out onto the Great Barrier Reef every year and they swim there. And they say they've never seen it so flourishing. It's doing just fine, thank you very much. So when I first visited Australia, I didn't really believe it existed until I got there. And it's a wildly improbable place, and they'd all fall off the earth anyway. But it does exist. And so I met Professor Bob Carter, now Mary in Heaven, who was at that time a professor of geology. And I said to him, look, you're at Otago University, you know all about the Great Barrier Reef, you know about all this stuff. Can you explain all about ocean acidification? He said, yes, I can. He said, you're too young to remember, but if we go back 54 million years to the Paleocene, Eocene temperature maximum, there was a period of 1,200 years over that period when the oceans were actually acid. In other words, they had a pH below 7. 7 is neutral. And it's a logarithmic scale. Now, just to put this in context, rainwater is pronouncedly acid. It's 5.